So here we are on our game board. We're on Conserve, which is 3.2H on our game board. I'm going to remind you again, like I did the last two videos, that if you look for this in your textbook, it's actually in Unit 1 of your textbook, Lesson 5, States of Matter. So in this part of the lesson, we're going to talk about what happens to matter when a change of state occurs. One of the basic laws in science is that matter can't be created and it can't be destroyed. Remember that you have to know the 4 states of matter, the definitions of them. You have to be able to explain the heat curve graph. Where is melting occurring? Where is freezing occurring? Where is condensation occurring? Is it a loss of energy? Is it a gain of energy? So that will definitely be on your test. So number 23 is an active reading, and it asks you to underline the ways particles of matter are affected by a change in state. Then you go down to number 24 and it asks you to model. And so what you're going to do is that you're going to draw the different phases in these boxes and put which state of matter you have on here. So as you go this way, energy is being added. As you go this way, energy is being taken away. This is more or less that heating curve. So you start out with a solid, you draw what it looks like. Make sure to include some side notes about energy, about how close the particles are, how they're moving, that sort of thing. And then you go, what's going to happen to that solid if energy is added? And you're going to draw and annotate that picture. So you have 4 pictures total, and you're more or less explaining that heat curve that we've already gone over. So in this slide, we're going to talk about mass isn't created nor destroyed. And so in a chemical reaction, like the one over here on the right, the mass of the wood plus the oxygen it needed to combust is going to equal the mass of the ashes. And if we could trap the carbon dioxide gas and the water vapor gas, it would be equal. So if this was 100 grams, this would be 100 grams. So as we watch this animation here, this is a classic experiment where we have Coke in the bottom and we have baking soda up here on the top of the balloon. And so they're going to dump the baking soda down into the bottle and a reaction is going to occur. It's going to bubble up. The carbon dioxide gas that is being produced will rise up and fill up the balloon. And watch the mass. So if we didn't have the balloon on top of there after we added the baking soda, we would see a change in the mass because that carbon dioxide would be escaping out into the air and out into the atmosphere. And so the scale would account for that we would be losing some of that carbon and oxygen. So I'm going to back up. I think I'm going to back up. There we go. I'm going to play it again. And we stay at that 9.6 grams. Okay, so the next slide. On page 101 is this experiment. It asks you, a flask of water is sealed with a balloon and heated to various temperatures on a hot plate. Fill in the missing information below. And so here you got energies gained, and we go to here. But when energy is what? Here it asks, what is the mass? And the same thing over here. You have some blanks. Energy is what? And I can't see underneath here. Yeah, it asks you for the mass. So take a little minute to contemplate that and get those answers filled in. The next question is a claims, evidence, and reasoning question. And I'll try to remember to photocopy this for you guys and have you put on the back of your binder. We're going to be using CER for the rest of the year. So make a claim. You cite at least 2 pieces of evidence that support your claim, and then reasoning on how this evidence supported your claim. CER. It's a buzzword in science education, and we'll be using it as the year goes by. And now that's it.